Hello students. So let's continue with the next problems in the second exercise. So the next question, find the LCM and HCF of the following integers by applying the prime factorization method. Okay. Actually, in the previous video, we had studied what is fundamental theorem of arithmetic and the difference between prime numbers and composite numbers, and we had solved few problems, isn't it? So let's recall what is fundamental theorem of arithmetic. That is fundamental theorem of arithmetic is simply any composite number can be expressed as product of primes, and this representation is unique except the order. Okay, you can, for example, 10 can be written as 2 into 5 or 5 into 2. But if you take composite number 10, it can be expressed as a product of primes using only 2 and 5. You cannot have any other prime number there, isn't it? So, and using this fundamental theorem of arithmetic, we were able to find the HCF and LCM. So what is the rule for HCF? We have to take the common prime number, same prime number with their least powers. Whereas for LCM, we have to take the all the prime numbers that are involved with their highest powers, isn't it? That is what we did. Also, we discussed a relationship, that is HCF into LCM is equal to product of the numbers. Suppose you are taking two numbers, LCM of those two numbers into HCF of those two numbers is actually equal to product of those numbers itself, isn't it? This is what we discussed. Let's continue with the problems. So the next main, find the LCM and HCF of the following integers by applying the prime factorization method. Okay, the first question is 12, 15 and 21. Okay, so 12, 15 and 21. 12, 15 and 21. As usual, let's prime factorize them first. So 2 6 are, 2 3 are, 3 1s are. Therefore, 12 can be written as 2 square into 3, isn't it? Similarly, 15 can be written as 3 5s are, 5 1s are. Therefore, 15 can be written as 3 into 5. Now coming to 21, 3 7s are, 7 1s are. Remember, we are supposed to use only the prime numbers. So 21 can be written as 3 into 7. Now coming to the HCF, what is HCF? The common prime numbers with their least powers. Now among all these three, which is the common prime number? It is 3, right? 3 is here, here, here. With its least power. Least power is 1 itself. So 3 power 1. So HCF will be 3 power 1, that is 3 itself. So HCF is 3. Coming to LCM, all the different prime numbers involved with their highest powers. So we have got 2, 3, 5, 7. These are the different prime numbers, isn't it? So 2 into 3 into 5 into 7 with their highest powers. So 2 highest power is 2 itself, 2 square. 3 highest power is 1, 5 highest power is 1, 7 highest power is 1. Okay, the highest power of 7 is 1. So 2 square is 4 into 3 into 5 into 7, which becomes 4 3s are 12. 12 5s are 60, 60 into 7 is 420. So LCM is 420, HCF is 3. So the same procedure, we have to prime factorize the numbers, then we have to follow the rules. Okay, let's get into the second question. Let's see what is the second question. Find the HCF and LCM of 17, 23 and 29. Okay, 17, 23 and 29. Now we have to prime factorize this. But what are these numbers? 17, 23 and 29 are basically prime numbers, right? So you cannot further express them as primes because themselves they are prime. So 17 can be written as only 17. 23 can be written as 23. 29 as 29 itself. There is no other way that you can represent them, right? Remember, you should not write 17 into 1, 23 into 1 because 1 is not a prime number. Okay. Now, what is common among this? There is nothing common. So if there is nothing common, then we take HCF to be 1. Why? Because 1 is the number that divides everything, right? So basically what is HCF? We have to find the highest number that divides all the three. So there is no common numbers that divides all the three, but we know that 1 is the number that divides 17, 23 and 29. Therefore 1 is the only number which divides all the three. Therefore the HCF is 1. Okay. Now coming to the LCM. What is LCM? All the different prime numbers involved with their highest powers. So different prime numbers involved are 17, 23 and 29 themselves. The highest power is 1, 1, 1, isn't it? Therefore, it is 17 into 23 into 29. So, whatever you get the answer on multiplication, that's the LCM. Okay. Here, I would like to introduce a new word known as coprime. Okay. A very, very important coprime. So, two numbers are said to be coprime if they don't have any common factor. For example, let's take 8 and let's take 3. What are the factors of 8? The factors of 8 are 1, 2, 4 and 8 itself. The factors of 3 are 1 and 3 itself. Now, what are the common factors among them? The common factors among them are only 1. So, these two numbers are called as coprimes. In simple words, which is the number that divides both 8 and 3? Which is the number? Or the HCF? I can say it as HCF. What is the HCF of 8 and 3? It is 1. Okay. Or as I said, which is the number that divides both? 1 is the only number that divides both. So 8 and 3 are called as coprimes because they don't have any other common factor other than 1. Meaning there are no other numbers which divides them except 1. 1 is the only number that divides both. Similarly, if I take 3 and 7, which is the number that divides both? It is only 1. Other than 1, there is no number which divides both. Or let's take 3 and 14. Let's take 3 and 14. Which is the number that divides 3 and 14? Both. Individually, yes. If you consider individually, we have got many factors, but together, there is only one number which divides them both, which is that 1. Okay, therefore, these are called as coprimes. Okay. So let's continue with the next problem. Third question. Third question is 8, 9 and 25. Okay. 8, 9 and 25. So the prime factorization of 8, 2 4s are 8, 2 2s are 4, 2 1s are 2. Therefore, 8 can be written as 2 cube. 2's come for 3 times, so 2 cube. Similarly, 9, 3 3s are 3 1s are. Therefore, 9 can be written as 3 square. Then 25, very easily 5 square. Because 5 5s are 25, 5 1s are. Now coming to HCF, which is the common prime number? There is no common prime number at all. If there is no common prime number, we take HCF as 1 because 1 is the only number that divides all the three. Okay. Now coming to the LCM, we have to take the different prime numbers involved. The different prime numbers are 2, 3 and 5 with their highest power. So obviously 2 cube, 3 square, 5 square. So 8 into 9 into 5. So it becomes 8 5s are 40. 40 into 9 is 360. Okay. So the LCM is 360 and the HCF is 1. Okay. So this is the third question. So let's get into the next one. Fourth question. Given that HCF of 306, 657 is 9, find the LCM of 306, 657. Okay. 306, 657. So what they've given us is, fourth question, HCF of 306, 657 is 9. What is the LCM of 306, 657? Question mark. Now, we know a relationship that HCF of two numbers, let's say A and B, into LCM of two numbers, A and B, is actually equal to product of themselves. So A into B. So here our A value is 306, B value is 657. So HCF of this into LCM of 306 comma 657 is actually equal to 306 into 657, isn't it? So A is 306, B is 657. So we have done it. So HCF is given as 9. 9 into LCM of 306 comma 657 is equal to 306 into 657. We need LCM. We don't need this 9. Do we need this? No. So let's transpose it. Let's send it the other side. It's in multiplication. These two are in product. So if I send it the other side, it will become division. It goes to the denominator, right? 306 comma 657 is equal to 306 into 657 divided by 9. Remember, do not multiply these two things because it is always divisible. You can cancel it. 9 ones are 9, 9 threes are 27, 3 carry 36, 36, 9 fours are 36. So 34 into 657. If you multiply this 34 into 657, I'll make use of the calculator so that let me finish it quickly. 34 into 657 is 22338. So 22,338 will be the LCM. And here I said it is obviously divisible. Why? What is HCF actually? The number 9 here is HCF, right? It obviously divides the two numbers. Highest common factor. Factor in the sense it's going to divide the numbers, right? So HCF of these two numbers is 9, meaning this 9 will divide both. So you can also cancel out this if you wish. Okay. So very important relationship. HCF of two numbers into LCM of two numbers is actually the product of two numbers itself. This is applicable only for two numbers, not for three numbers. Even in the previous video, I had mentioned this. That is HCF of A comma B comma C, LCM of A comma B comma C. You cannot write it as A into B into C. This is not valid. Okay. This result is valid only for two numbers. Okay. Let's solve the next question. Okay. The next question. Check whether 6 to the power n can end with the digit 0 for any natural number n. Okay. So what they have given us is 6 power n. We have to check it out whether this will end with digit 0, meaning give values for n. So if you give n as 1, you get 6 power 1, which is 6. If you get n as 2, it implies it is 6 power 2, 36. If you give n as 3, 6 power 3, 216. If you give n as 4, 6 to the power 4, whatever you get. Okay. So as and then you give n, is there any value of n such that this number is going to end with 0? Okay. We have to check, is it possible? See, we have checked till n is equal to 3. We don't know, maybe n is equal to 10, maybe it ends with 0. We don't know. But we cannot do that, right? N is equal to 10, 6 power 10. We cannot multiply 6 into 6 into 6. So on 10 times and check whether we're going to end with 0 or not. So we're going to make use of fundamental theorem of arithmetic here. Okay. So it's very simple. We have to check whether this ends with 0 or not. Remember, any number which ends with 0 will have 2 and 5 in it. Okay, meaning when you prime factorize it, it will have 2 and 5 in it. For example, let's take 30. This is a number that is ending with 0. So if I prime factorize it, it will have both 2 and 5. Actually, this is the prime factorization of 30, right? 2 5s are 10, 10 3s are 30. You take any number that is ending with 0. For example, let's take 110. This actually can be written as 2 into 5 into 11. So you can observe this pattern. Any number that is ending with 0 will have definitely 2 and 5 in its prime factorization. This is ending with 0. So 2 and 5 is there in its prime factorization. This is ending with 0. So it has both 2 and 5 in it. So basically, if 6 power n has to end with 0, then the prime factorization of this should have both 2 and 5 in it. Okay, let's check whether the prime factorization of this has got both 2 and 5. Now, forget about this n. Now, let's just prime factorize 6. Prime factorization of 6 is 2 3s are 3 1s are, meaning this 6 can be written as 2 into 3, which implies 6 to the power n can be written as 2 into 3 whole to the power n. So here, whatever be the value of n, let whatever be the value of n, even if you give 100, you can split it and write it as 2 to the power 100 into 3 to the power 100, isn't it? So the law of exponents, a into b whole to the power m can be written as a to the power m into b to the power m, isn't it? Using that, you can do it. So what I'm trying to say is, let whatever be the value of n, don't worry about the value of n. We will always have 2 and 3 in the prime factorization, isn't it? Whatever be the value of n, we'll have just 2 and 3. We don't have 2 and 5, which means 6 to the power n, let whatever be the value of n, it never ends with 0. If it is ending with 0, then we would have had somewhere here 5, isn't it? If you prime factorize it, you should have both 2 and 5. So it is not at all possible. It doesn't depend on the value of n. It doesn't depend on the value of n at all. You give whatever value of n. This doesn't change, isn't it? If this doesn't change, then there is no possibility that 6 to the power n is going to end with 0. Okay. So somewhere if most of them will check only for 5. If the prime factorization is containing 5, if it is not containing 5, then it is not ending with 0. That is what in the textbook, if I'm not wrong. But the precise one will be 2 and 5, because let's say 15 to the power n. This is a completely different thing that I'm saying now. See, this is the question which we have already discussed. The question was 6 to the power n. Will it end with 0 for any value of n? No, it is not possible. Why? Because both 2 and 5 are not in the prime factorization. Simple. Done. Okay. Now in the textbook, it is given for the same type. There is another question, a similar type, 4 to the power n. If you prime factorize it, you get 2 square whole to the power n, which can be written as 2 to the power of 2n. Using laws of exponents, power raised to power, you can multiply it. So they have told the prime factorization doesn't contain 5. The prime factorization doesn't contain 5. Therefore, it is not going to end with 0. Actually, the thing should be the prime factor doesn't end with 2 and 5. I mean, doesn't contain 2 and 5. It is already, this is having already 2. That is why they have concentrated only on 5. Okay. They have not discussed about this 2. Even here, see, if I prime factorize this, I will get 3 into 5 whole to the power n. Okay. Now, according to the textbook, if you go like that, it says this is not having 5 in prime factorization, therefore it cannot end with 0. But if you observe here, this is having 5 as a prime factor in it. But definitely this is not going to end with 0 for any value of n, because it doesn't have 2. So the thing should be 2 and 5. Okay. In the textbook, they have concentrated only on 5 because there is already 2 over here. So that is why they are concentrating on 5. So the actual concept that you have to remember is, if it has to end with 0, then it should have both 2 and 5 as prime factors. Okay. So let's get into the next question. So in the next question, explain why 7 into 11 into 13 plus 13. So 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 1 plus 5 are composite numbers. Okay, we have to explain why this and this is a composite number. Now let's just recapitulate what exactly is a composite number. Simple. A number is said to be composite if it has got more than 2 factors. That is, usually every number, you take whichever number, it will have 1 as its factor and the number itself. So that is, for example, you take 158. Very easily, I can say 1 is a factor of this and that number itself. Any number, for any number, 1 and itself is a factor always. Because 1 divides this number also divides itself. So every number has got 1 and that number itself as the factor. Now, apart from this 2, if it has got some more factors, then we call it as composite. Suppose 2. Definitely, it has got Apart from these two, it has got one more extra factor. Therefore, I can call it as composite number. I hope it is clear. Composite number in the sense it will have more factors. Prime numbers will have only two factors, which are those 1 and itself. Now, if you observe carefully, 7 into 11 into 13 plus 13. I can take, observe, all this thing is considered to be one term. If it is in product, this entire thing is considered to be one term. And this is another term because there is a plus symbol. From these two things, I can take 13 as common, isn't it? If I take 13 as common, so 7 into 11 plus 1. So I took 13 outside, so it will be 1. So 13, 7 into 11, 7 into 11 is 77 plus 1. So 13 into 78. Okay. Now very clearly observe this number, if you finalize this, if you multiply it, how much you get? 104 and 91. 814. Okay, if you simplify this, you get 814. Now very clearly 814 can be written as 13 into 78, meaning this number can be divided by 13 and can be divided by 78, which means this has got more than two factors. One is a factor of it, 814 is a factor of it, and 814 can be written as like this, isn't it? Therefore 13 also divides this, 78 also divides this, which means this has got more than two factors. Since it has got more than two factors, this is a composite number. Same explanation for this. Okay, you can take 5 common here. Okay, whatever number you get, it has got more than two factors. That is why it is known as a composite number. Okay. Otherwise, see, if it is a prime number, there is only one way you can represent it. For example, 3 can be written as 1 into 3 or 3 into 1. There is no other way. But if you take 6, it can be written as 1 into 6, or it can also be written as 2 into 3, meaning 2 also divides 6, 3 also divides 6, 1 also divides 6, 6 also divides 6. If a number can be expressed in 1 or 2 or more ways, then it is called as a more than 2 ways actually. If a number can be expressed in more than 2 ways, then it is actually composite. See, 814 can be written as 1 into 814 or 814 into 1. Apart from that, I can also write it as 13 into 78. There are still more. Okay, basically this number has got more than two factors, therefore it is called as composite number. Same explanation is valid for this. So let's get into the next question. Okay, in the next question, 7th one, that is the last question of this exercise. There is a circular path around a sports field. Okay. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction, and after how many minutes will they meet again at the starting point? Okay, a very interesting question. So there is a circular path around a sports field. Let's say there is a field. Let's say we have got a circular path. Okay, let's say this is the starting point. Okay, we have two persons, Sonia and Ravi. Okay, now Sonia takes 18 minutes to complete one round. She takes 1 minute. Suppose she's starting from here. She takes 18 minutes to complete one round, while Ravi takes how many minutes? Ravi is taking 12 minutes. Okay, Sonia is taking 18 minutes while Ravi is taking 12 minutes. So basically Ravi is taking less time to complete one round, while Sonia is taking more time to complete one round. Okay, now what is the question? Suppose they are starting at the same point at the same time. Okay, let's say at time t is equal to 0, they start. Now I have to find after how many minutes will they again meet at starting point, because it's very simple. See, Ravi after 12 minutes he would have completed one round, but Sonia she'll be somewhere here, I guess. She takes 18 minutes, right? She'll be somewhere here. So when Ravi is here, already completed one round, Sonia will be somewhere in the halfway, more than halfway, right? So it will take some time for them to meet again at the starting point. Okay, we have to find that time. Okay, now observe an interesting thing here is, now at time is equal to 0, Ravi starts. Let's concentrate only on Ravi. Okay, after how many minutes will he complete one round? 12 minutes. That is given. Now to complete the second round, how many minutes will he take? 12 minutes. Again at 12 minutes. So it will be in total 24 minutes you would have completed second round. Starting one round, second round, third round. By third round, how much time you would have taken? 36 minutes. And fourth round, you would have taken 48 minutes. If you observe properly here, the time that he is taking is multiples of 12, isn't it? Because 12 minutes. Next time, to complete 2 rounds, you would have taken 24 minutes. To complete 3 rounds, 36 minutes. To complete 4 rounds, you would have taken 48 minutes. So basically, the time here is multiple of 12. If you apply the same logic for Sonia, this is for Ravi, Sonia, after how many minutes will she complete? 18 minutes. Then the second round, 18 plus 18. So 36 minutes. 18 plus 18 plus 18. Okay, 54 and so on, isn't it? Now, we have to find, this is the logic, right? So the time that we are trying to find should be a multiple. Okay, let me put it in this way. Can Ravi complete one complete revolution, let's say in 50 minutes? After 50 minutes, will he be in starting point? Definitely no, because at 48 minutes itself, he would be in starting point. 50 minutes, he would have crossed it. In other words, this 50 is not a multiple of 12, isn't it? This 50 is not a multiple of 12, or this 50 is not divisible by 12. I can also tell it like that. Okay, so the time that we are trying to find should be a multiple. Okay, since both have to meet at starting point, then the time that I'm trying to find should be a multiple of 12 as well as 18. It should be common for them. Okay, and the question is, what is the least time that they're going to take? So I have to find least common multiple. I repeated, if there is any confusion, just focus. See, I'll be able to be or meet the starting point only if it is multiple of 12 here. See, 12 minutes, I'll be at the starting point. 24 minutes, again, I'll be at the starting point. 36 minutes, I'll be at the starting point. 48 minutes, I'll be at the starting point. At 50th minute, will I be in the starting point? No, I would have crossed it. I'll be somewhere here, isn't it? So meaning this 50 is not divisible by 12, isn't it? So those numbers which are divisible by 12 at that minute, for example, 60th minute or 72nd minute, I'll be near the starting point. Same thing applies for Sonia. Okay, she'll be at the starting point at the 18th minute, 36th minute, 54th minute, 72nd minute, 90th minute, and so on, isn't it? So if both have to be at the starting point, then I have to find a number in such a way that that is a multiple of 12 as well as multiple of 18, meaning a common multiple. So I'm trying to find the least number. Therefore, I have to find the LCM of 12 and 18. That is a logic. Okay. So LCM of 12 and 18. So 12, let's prime factorize it. 2 6s, 2 3s, 3 1s. 18, 3 9s, sorry, 3 6s, 3 2s, 2 1s. Therefore, 12 can be written as 2 square into 3. 18 can be written as 2 into 3 square. What is the LCM? All the different prime numbers with their highest powers. So 2 square is 4, 3 square is 9. 9 into 4 is 36. If you observe here itself, you would have got at the 36th minute, she is also at the starting point, he is also at the starting point. Definitely they would have covered different number of rounds. This fellow is in the third round, but she is in the second round. That doesn't matter. We have to find at what time they'll meet. So after 36th minute, so during the 36th minute, both will be at the starting point. I hope you have understood this. Thank you, students.